Computer Vision Breakthroughs, synthesizing 93 papers from 2025 September 19th to 2025 September 19th, exploring cutting-edge AI that empowers machines to see and interpret the world, featuring innovations in medical imaging, robotics, and 3D generation. Presentation overview. Diving into the pulse of computer vision research. Imagine AI turning selfies into dancing 3D avatars or diagnosing medical scans. This episode unpacks 93 papers from September 19, 2025, blending themes into an exciting narrative. From field foundations to future trends, complex research is made accessible and fun. A paper of the day is highlighted amid key discoveries and methodologies. Join this guided adventure through pixels and algorithms reshaping reality. Field overview. Understanding computer vision. Computer vision enables machines to interpret images, videos, and 3D scans like human eyes. Deep learning is drawn upon to process pixels into insights such as spotting tumors or navigating streets. Impacts are seen in healthcare, robotics, environmental monitoring, and everyday apps like facial recognition. Integration with text or audio occurs for multimodal AI, addressing challenges like noisy data or biases. Rapid evolution proceeds with ethical considerations, from privacy to reliable, real-world applications. Research Theme 1, Medical Imaging and Analysis, Advancing Diagnostics with Vision Tech. A key theme is enhancing healthcare through accurate image analysis. Agarwal et al. Views CNN-LSTM for 98.6% gait abnormality detection, aiding Parkinson's diagnosis. Novel texture descriptors achieve 100% thyroid cancer classification on ultrasounds. Key FedSam enables privacy-preserving segmentation across hospitals. These innovations make diagnoses faster, interpretable, and resilient to noise. Research Theme 2, Robotics and Autonomous Systems, Perception in Challenging Environments. Focus is placed on enabling safe navigation in real-world settings like underwater or foggy conditions. Wu et al. Adapt stereo depth estimation, boosting underwater robustness by 5 to 6%. Gaussian-based detectors improve 3D radar sensing for self-driving cars with faster inference. Knowledge-augmented models hit 95% accuracy in indoor action recognition. Bridges are formed to efficient robotics for exploration, safety, and human interaction. Research Theme 3, Generative and Reconstruction Techniques, Building 3D Worlds from Data. Realistic scenes and objects are created, like 3D forests from aerial scans. Hybrid 2D-3D methods achieve state-of-the-art geometry in augmented reality. SceneForge composes multi-object scenes aligned with text for zero-shot tasks. GS-Scale optimizes Gaussian splatting for massive datasets, reducing memory by 5.6 times. High-fidelity reconstructions fuel VR. Urban planning and simulation. Research Theme 4, Robustness and Multimodal Integration, Defending AI and Fusing Senses. Vulnerabilities are addressed, and vision is combined with text or audio for richer understanding. Pai et al. Mitigates sycophantic behavior in multimodal models via reflective tuning. Tensor decomposition restores 12.3% performance against adversarial attacks. Unify fuses visible infrared images for night vision improvements. Reliable AI is ensured in critical areas. Closing gaps in biases and misinformation. Key findings. Critical insights from the papers. In medical applications, 100% accuracy in thyroid cancer classification is achieved via resilient descriptors, as in Agarwal et al. In robotics, 95% action recognition is reached with knowledge augmentation, enhancing safety. Generative approaches see hybrid methods topping benchmarks in 3D reconstruction without overfitting. Defense mechanisms provide 12.3% recovery from attacks using lightweight tensor fixes. Multimodal advancements yield a 72% boost in image generation accuracy through temporal rewards. Methodology. synthesizing common approaches. CNN-LSTMs handle spatial temporal data, like gait sequences, for high accuracy but are compute-heavy. Transformers capture long-range dependencies in tasks like action recognition, with attention focusing on key image parts. Diffusion models refine noise into 3D outputs, offering diversity yet slow inference. Self-supervised learning uses unlabeled data for scalable training, reducing label needs. Knowledge distillation transfers from large to small models for edge efficiency. Selected Research Paper 1. Explainable Gait Abnormality Detection Using Dual Dataset CNN-LSTM Models. By Agarwal et al., 2025. Selected for Healthcare Impact and Interpretability Breakthrough. Objective: accurate, explainable detection of gait issues like Parkinson's. Method: dual-branch fusion of 1D joints and 3D silhouettes with SHAP GradCam. Findings: 98.6% accuracy, outperforming baselines in clinical settings. Significance: builds trust in AI medicine. Novel for crossing data silos. Selected Research Paper 2. Paper of the Day. StereoAdapter. Adapting stereo depth estimation to underwater scenes. By Wu et al., 2025. Chosen for robotics innovation in harsh environments. Objective: efficient depth adaptation for underwater robotics without heavy retraining. Method: LoRa fine-tuning with recurrent refinement on synthetic datasets. Findings: 5 to 6% robustness boost, proven in real BlueROV 2 tests. Significance: democratizes autonomy for marine applications, extends to other domains. Selected Research Paper 3, Pointing to a Llama and Call it a Camel on the Sycophancy of Multimodal Large Language Models, by Pai et al., 2025. Picked for addressing AI trustworthiness and novelty in multimodality. Objective: reduce misleading agreements in vision language models. Method: sycophantic reflective tuning with self-reflection on datasets. Findings: errors cut from 40% to under 10%, balancing flexibility. Significance: enhances reliability for education and healthcare, counters misinformation. Future directions: next steps in computer vision research. Neuroscience is integrated for brain-like processing in unified models. Edge computing and federated learning are advanced for low resource efficiency. Ethical biases, privacy, and compute demands are tackled with quantization. Quantum methods are explored for faster 3D rendering and bio-inspired defenses. Deeper embedding into daily life occurs, from personalized medicine to sustainable monitoring. AI synthesis and review. How this deck was created. Synthesis occurred using AI tools. GPT Grok with model Grok 40709 for content generation. TTS synthesis was handled via OpenAI for audio narration. Image generation utilized Google for visual elements. Review was conducted by a human expert to ensure accuracy. Note: some oversights may exist. All references are provided for verification. Subscribe and channel info. Stay updated with AI frontiers. Subscription to the YouTube channel is encouraged for more cutting-edge AI research insights. Title: AI Frontiers. Description: blank. Join to explore the latest in artificial intelligence and computer vision. Hit subscribe and turn on notifications for daily updates. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.